As you said, I'm very much interested in sea level rise. I'm a sea level scientist, and I wrote a report last year looking at facilities aligned with the Trident programme and where the threat of sea level rise is. I've had an interest in infrastructure on the coast for a long time, and have also looked at energy facilities and the risk of sea level rise support infrastructure. But I'm going to focus particularly in this presentation on the Trident programme and their sites. So I'm going to start with a bit of background to climate change, relative sea level rise, and a little bit on flood risk, and then think about the implications for Trident sites. So this is just a very much of a background relating to the science, and then something more specific that's targeted. So to start with, a bit of background. Many of you might have seen on the news this week, and also in the previous few months, that there's been a lot more on climate change. And this is because one of the main global organisations, the Intergovernmental Panel on Climate Change, or the IPCC, has been publishing some major reports. The IPCC is a global body formed of different scientists who are invited to write for them. They're selected by their governments. And it's like the Bible of climate change. And there was one out this week on 2 days ago saying about mitigation and also just very concerned about climate change. But there has been a series out. So the information I've got in this talk does come from those reports and the last few over these years. And the first thing I'd like to draw your attention to here is that we see that in the last decade, global surface temperatures have been about 1 degree warmer than around 150, 170 years ago, so a long time. We're looking at these long-term change where we have a 1 degree rise in temperature from pre-industrial times, from 1850 to 1900. And although that doesn't sound very much, it can potentially be a lot because it's a global average. And we might have some places that are above average, some places that are below average. We also might have changes in seasons as well. So although 1 degree doesn't sound very much, it's very important. And we're expecting those temperatures, that temperature increase to continue into this century and beyond, even if we mitigate, i.e. reduce greenhouse gas emissions. And we look at that by looking at scenarios of change. And one of the things that the IPCC says is that future change under a mitigation scenario, so that's one where we reduce greenhouse gases a lot, may be 1.7 degrees warmer in the middle of the century. But if we look towards the end of the century, it could be a lot more under a non-mitigation scenario. So we could be going up to 4 degrees. So we're seeing quite a variation in what our future temperature could be. Future temperature rise isn't good for many reasons. A little bit of temperature variation we would expect, but big changes in temperature where we're going up between 1.7 to 4 degrees isn't good because it changes a lot of things around our planet as we live in a very dynamic system. And it also means it affects sea levels as well. We can measure sea level around the world. So we can measure from tide poles. Literally, you can see that one there. You can see how high the water level is. We've got tide gauges, which is the middle image, and that one indicates the rise and fall of the tide. And we can take the average of that to understand where mean sea level is over time. And in the last kind of 30 years, we've also got satellites measuring from the satellite, looking at the height of the sea level all around the world. So very, very accurate numbers. And what scientists have found is that over the course of around a century, so just under a century in these numbers, 1.4 millimeters per year of sea level rise has happened. Again, there's been places around the world where sea level's been a bit higher and a bit lower, but on average, it's 1.4 millimeters per year. But there are concerns that in recent decades, or the last half century, that pace of sea level rise is increasing, and we may be seeing 2 to 3 millimeters per year of sea level rise. So this means that we've got this problem of temperature rise that we know is going to be increasing, because that's what the models say, and that's what we're seeing from the records. And we've also seen long-term sea level rise as well. And we're also going to see that sea level going to continue to rise. So that's one part of the story. So we're going to see this long-term sea level rise. How much I'll get onto in a moment. But we also see changes in our land level as well. So when we think about the last glaciation, which disappeared about 12,000 years ago, the ice left a big imprint on the Earth. It pressed down on the Earth's crust, and that crust is slowly rebounding. but that's not uniform. So we see this crust rebounding really, so we're getting land uplift in Scotland. It's very slow, could be about 1 millimetre per year. But the land in the south of England is sinking as a result of all these changes. So all in all, we've got some sea level rise, and we've got some land uplifting in the UK, and we've got some land sinking. Now, if you've got land uplifting and sea level rise, that might be okay because they might both go up together. But if we've got land sinking and we've got sea level rise, so we've got sea level rise going up, got to go this way, and then we've got down land that's sinking, it means that we're going to have something called relative sea level rise, where we get quite a big difference between where the land level is and where the sea level is. And that's a really big concern. And that means that we have long-term concerns that we might get greater flooding in the future if our sea defences don't withstand that rise, or our port facilities and everything around that port is actually going to be at risk because you just can't jack up the port very easily. And that's where it becomes a problem with some of the Trident sites, that we don't really know the history behind these sites, at least I don't, in actually understanding what the risks are. So in the second part of this talk, I'm going to be thinking about the implications for those Trident sites and the impacts and adaptation. So the Trident programme, in this report I wrote last year, I was asked to focus on 4 areas. The first 2 in Scotland, so Coalport and Fastlane, up on the west coast of Scotland there. I was asked to focus on Barrow-in-Furness, up in the north of England, again, west coast, and also Devonport in the southwest. Now, the nice thing about these is that they're located in the north, middle, and south of the country. So when we're thinking about that land level change, if I just go back to this figure here, the one on the right-hand side, in Scotland, we've got land uplifting, but we've got in the south land subsiding. So in Devonport, we've got land sinking, as well as thinking about overall sea level rise. So these are the 3 areas that I was asked to study. Now, if I just zoom into those a little bit more, these ports are generally up estuaries. Estuaries is where the rivers meet the sea. They're generally more protective areas and going into locks as well. And that's a good thing because it means the waves don't get to the ports quite so much. They might also be enclosed, as you can see in Barrow-in-Furness. So this is the middle image here. And that's actually really good because if you've got the waves, those sites are much more protected. So I was asked to look at these sites to actually say, well, what does this mean for sea level? So the first thing I wanted to do was to understand how past sea levels have risen in these areas. This is an example of some tide gauges that measure relative sea level rise. We've got here 3 sites. So we've got Millport, which is the one nearest to the 2 sites in Scotland. We've got Plymouth and Heysham, again, nearest to Barrow-in-Furness. So we've got the red in Scotland, we've got the purple is the north of England, and the green is in the south of England. Along the x-axis, we've got time going back to 1960 up to 2020. And along the y-axis, we've got relative sea level rise. Now, here, that we don't have a scale here as such, like a scale that you might see on a traditional graph, because we have to offset these so you can see each of the tide gauge records. But 3 squares there equals 3 rectangles, say, is 300 millimeters. Now, if we take the top red line, we see a mean rise, so an average rise of 1.5 millimeters per year. We go down to the north of England and we got 1.8 millimeters per year, and we go down to the south of England near Plymouth, and we got 2.4 millimeters per year. So this threat of sea level rise we're seeing across the country, but is particularly pronounced in the southwest in Plymouth. And there's lots of ups and downs. That's what we would expect because the tides do move up and down, and we've got big changes in the oceans that happen over many decades. But the overall trend that we see over half a century or so, we're seeing is going up. And that's a really, really important thing. So the question is, well, what does that mean for the future? Now, we can look at scenarios of change for the future to see how much sea levels are going to rise. And this is my first one. So this is my first sort of a lot to look at in this one. So we've got 3 images here. So we've got Coalport and Fastlane on the left. In the middle, we've got Barrow-in-Furness, and then on the right-hand side, we've got Devonport. And each of these images indicates the level of relative sea level rise. So how much sea levels are going to rise relative to the land. We've got some uncertainty, which is why we've got 3 lines. And overall, this indicates a non-mitigation scenario. So this is sort of the good end. We've got time here going from 2000 to 2100. What we're indicating here is that we could expect sea level rise. We concentrate on the middle line, the green line. We're looking at the 50th, so the mean. We could be experiencing sea level of around 25 centimetres, but we could be up to half a metre by the end of the century, depending on what location we're looking at. So that means that we're going to see some changes. If we look at the non-mitigation scenario, so this is exactly the same figure, and we look at sea level change, again, if we look at that green line, first of all, the one on the left, the Scottish one, has gone up from about 25 centimetres to in excess of 50 centimetres by 2100. So we're seeing a very different change going on here. And the same if we go up to Devonport, we're going in nearly a metre of sea level rise. So we've got a real concern here that we've got sea levels rising and we don't know what that means for protection on the land. Now we could continue these lines, we could go up beyond the end of the century, and we could be looking over, say, 300 years of maybe 2 or 3 metres of sea level rise. So we're seeing some very long-term changes, which are actually really important for the coast. So we have to think about how much sea levels are going to rise, but we also have to think about what's going on the land. So we might think about other sources of flooding. So we might get surface water flooding, we might get flooding from rivers as well, not just the sea floods and changes in storm surges. So this is a really important thing. So we've got lots of sea level change and lots of potential physical change is happening. So we have to think about adaptation. Adaptation is about the process of adjustment to the actual effects of climate change and that could potentially cause harm. It's about exploiting opportunities to try and reduce risk. And this was also pinpointed by the UK government to make provision to adapt to climate change as the UK's Climate Change Act in 2008. And so the UK has a duty to report on this with climate change risk assessments and also adaptation reporting as well. So there's different ways you can do this. So firstly, you could potentially raise seawalls. You could raise infrastructure, not just to the port areas themselves, but also to connections, because we know maybe like railways go inland. But you can't just do that overnight. You have to do this when infrastructure gets renewed anyway, because it's very, very expensive. The Office for Nuclear Regulation states that facilities should be able to withstand a design basis events of 1 to 10,000, and where this is not possible, a dry site concept. So we need to try and keep these sites safe. Now, the question is, well, what sea level scenarios should these sites have? We have recommendations. We should be using the high scenarios, but we do have further recommendations that we should be looking at the most severe scenario of maybe between 0.93 to 1.9 meters of sea level rise by 2100. So potentially double of what we were looking at previously. So these recommendations, it is actually really, really important about how high is your sea level going to be? What is the rate of sea level rise? So if you're thinking about nuclear power stations on the coast, it's really important to think about long-term change, because those power stations, whatever facilities are going to be there for a long time. We mentioned at the beginning about other nuclear power sites. This was some work that I did about 10 years ago now, where I was looking at different energy facilities around Europe, and that did include nuclear power stations. And I went around the coast and literally counted them up all around Europe. What the colours don't matter so much, but the circular blobs around each of the coast is where there is a nuclear or energy oil and gas site. And what this figure shows is that we've got a lot of these areas around the North Sea and also going up the West Coast, but it's particularly around the North Sea area and going into the Channel, where we're seeing a lot of energy port facilities and nuclear power stations that are very vulnerable to sea level rise. When we're looking about 15 years ago, there was quite low awareness in some countries. This is the shading now that I'm mentioning about the sensitivity and adaptation to sea level rise. That's changed a lot in the last 15 years. There's a lot more awareness now. But we've still got this legacy of infrastructure, coastal infrastructure on the coast that needs protecting. And if we're thinking about looking at new facilities, this is something that actually we need to think about how much sea level rise will be and what are the implications there. So in conclusion, sea levels are rising, and with storm surges, this could have an adverse effect on flooding. We're going to see relative sea level change, maybe in 2050, between 12 and 24 centimetres for a mitigation scenario. We're going up to 2100, 50 centimetres to 77 centimetres. I forgot my centimetres. No, sorry, that's right. 0.77 metres of sea level rise under the worst case, the non-mitigation scenario. So we're going to expect sea levels to rise. The highest rates are projected in Devonport in the southwest, the lowest up in Scotland. And adaptation means raising infrastructure. By how much is the question, and also adapting to other impacts of climate change as well. So there's a lot of food for thought there. It's about investing in a place for the long term and also making sure that we're adapting as well. So I'll leave it there. Thank you very much for listening, everybody. I'm happy to answer some questions at the end, but I hope that gives you a bit of an indication of some of the risks that we're seeing associated with sea level rise and nuclear facilities in coastal locations.